agenda I've got for today is, well, we're talking about business modeling. So what I first of all want to do is ask the question, what is a model? And then I'll talk about the types of modeling that we use really in IT for data, conceptual, logical and physical modeling. And then I'm going to talk about the differences between the business model and the logical and physical data models. Okay, so what is a model? Well, probably when you were young, or certainly the males amongst you, probably built some models, like a model aeroplane out of a kit or something like that. And this is a model, and we think of it as a model, and it is really, it's a replica of a real system. It looks like a real system, and it has something that is an exact copy of it. In this case, the dimensions of it. But models don't have to be physical like this. They may be, just trying to click on the right things, they may be a chart of accounts for a company, for example, a financial model, or they may be a model of the economy of a country. They may represent a mathematical type model, trying to get the best fit of something, cheapest price or something like that. Or they may be IT type models, where we have models of the business, models of data, models of the applications, models of the technology, all sorts of different things we use. So models come in many shapes and sizes, and they're not the real world, they're merely a human construct to help us better understand the real world. So they must be usable with respect to some purpose, and they must contribute some insight which is relevant to our subject area. One of the things that Einstein said was, you should make your theory as simple as possible, but no simpler. And this is true of a model as well. We want our models to be simple so that they understand, and they help us understand them, but they shouldn't be oversimplified. Okay, well, that's what a model is, I guess. But what I want to talk about are three different sorts of models which are key to IT and key to storing information about our businesses. One is a conceptual model, one a logical model, and the other a physical model. So let's talk about those three things. A conceptual model is really a model that tries to describe the concepts within our business. And it's used when building systems between the business analysts and the business representatives. And often they look something like this. This might be on a piece of paper or on a whiteboard, and it's a mechanism for communicating ideas. Now, when you've got that, hopefully you've got something in your brain from that, but it's not really all that useful to keep it, because it's not very memorable, not very structured. And it would be much better if we could have a model that was more structured, and a model something like this may be better, because you could keep that. So this is an example of a business model, a Kaleido business model, and it defines the real things that make up your business, like customers, suppliers, products, assets, transactions, and people. So, okay, so that's a conceptual model. What about a logical model? Well, a logical model is not really so much the domain of the business user, but it's the domain of the business analyst and the data architect. And it probably looks something more like this, a bit technical and complex. But it defines the data structures and the data elements that you're going to store. And it's about customers, suppliers, products, assets, transactions, and people. So the same thing, but it's a way in which the computers need to store the information. And then the third model, the physical model, it's really not the domain of the business analysts anymore, more the data architect and the DBA. And it's more complex. It replaces much of the information in the logical model by columns and foreign keys and data tables. And it is what enables the DBMS to store data about our customers, suppliers, products, assets, transactions, etc. So those are my three types of models. So let's just try and look at the differences between these three sorts of models. Well, the first and most obvious difference between a conceptual model or a business model and a data model is that the business model represents concepts. Well, that's pretty obvious, isn't it? So let me just look at a model. We've got a concept of a person here, and in the business model, the person represents the real thing, you or me. Whereas in the logical data model, it represents a data record about you or me. So what can you do with a person as represented in the business model that you can't do with a person as represented in a data model? Well, the answer is that you could employ a person, or you could make an agreement with them. You can shake their hands. They're real people. You can't do that with a data record. It wouldn't make much sense to employ a data record. But what can you do with a person as represented in a logical data model that you can't do with a person as represented in a business model? Well, you could copy it. It would really be nice to copy some people. Some people who are really good, we'd like to make a copy of them, a clone. And you can delete it. Well, we might want to delete some people, but that's not legal. So that really is trying to illustrate the difference of what we mean by what we're trying to model. So I'm going to start off looking at a logical data model. I'm doing this because this is something you've probably seen and would understand. So here's a model of an employee, and the employee would have a key and a department, a name, date of birth, gender, and a few things like that. But we might look at department and say, well, we ought to model that as something in its own right. So we'll create a new logical data entity, which we call department. It has a name and a few other attributes, and it might have a reference to the division that it's in. And then we might say, well, a division is a separate thing, so we'll have another item for that. So this is a good logical data model. Well, it's good for some things. It's good for holding a list of all the employees who are in a department and the departments that are in divisions. But there are some limitations here. What happens if you employ a contractor? Well, a contractor doesn't have an employee number. He's not employed by your company. So does that mean he can't be in the department? Well, this model says that's true. He can't be in the department. Well, we could fudge it, of course. We could invent a special employee number for this, but then we're not modeling our world. We're modeling just how we're going to put some data somewhere. So you can't really have people who are employed by a different company in your department. Furthermore, what happens when the employee moves departments? I guess most of you have moved departments in some stage in your career. Well, we can move him to the new department, and it represents a snapshot of which department the employee is in, but it can't actually tell you which department he used to be in. So this wouldn't be very useful for a personnel system which needs to hold records over time. Furthermore, the department is in a division at a point in time, and if we have a reorganization such that the department moves to a different division, we can't hold that either. We can only hold the snapshot. So this model is fine for a snapshot, but most of the time we want to do a little bit more than just have a snapshot of some data. So let's think about how we might model this if we were going to make it a conceptual model. Well, first of all, we have to ask the question, what is an employee? And an employee is a person, and the person is employed by a company. So we've got a few things here, a few concepts. We've got a person, a company, and an employment association. And the employment association really represents the fact that it is an employee. Now, this model allows a person to move company and still be maintained, and indeed the employment that he had with the company that he's moved from would still be maintained. So we can hold a history. But some people have more than one job. They work for two companies at the same time. Can this model support that? Well, yes, it can. You can have two employments at the same time for different companies. So here we have taken some concepts and implemented them rather than just implementing the data records. Now, we can implement data records like this as well, which would support our concepts. Let's now go a step further and look at the people who are in the department. Well, it is the people who are in the department, not the employees. So we ought to have a relationship like this, saying a person is assigned to a department for a period of time. And the person can move departments or can be in more than one department. So this enables us to have a person employed by one company but assigned to a department in another company. So we can support the contractors or the consultants. department within the division. Well, this is a composition of the division composed of a number of departments, and this may be one, or over time the same department might move into different divisions if we have some reorganizations. So this model, a conceptual model, allows us to have much more flexibility and to hold a history. Now, this is a conceptual model. I want to now draw it as a Kaleido data model, Kaleido business model. And I start off with a person. And the person has an employment with a company. Now, the model has some specific meaning here. The arrow is actually that association. And this is an association which is an employment association. It says that the person is in one company. The arrow indicates that it's just one. But it does a little more than that, because it says is in one company at a time, and it can be in a different company at a different time. So the single-headed arrow indicates one at a time. If we wanted to say that a person was employed by more than one company, we'd make an arrow on the other end of this in the Kaleido model too. But this is the normal thing that we do. We're normally interested in the employment of in one company. If we now look at the assignment to a department, we get the same sort of thing. The person is assigned to the department. The department is composed, or is part of a division, so the division is composed of departments. And in fact, the company is composed of a set of divisions. So now, if you look at a person, he can be in a department which is in a division in a company, and he can be employed by the same company, or he could be employed by a different company. They are different relationships. And so this business model depicts that and is fairly easy to understand and clear. Now, when I had the logical data record that we looked at before, there were a few things that I haven't really covered here. We had gender and marital status. And let's think about those things. They are really different concepts. The idea of gender is really independent of human beings, but we're going to apply it to human beings. But it is a classification of a person. So we ought to recognize that as a separate object, and it's got two values, male and female. And the fact is that it generally doesn't change. So if a person is male, he's male all his life. And it's really very exceptional for anyone to change their sex, but it could happen, I guess. But if we look at marital status, this is quite different. We have a number of marital statuses, but we expect those to change. A person is usually single, then gets married, then may be widowed or divorced. So it changes throughout their life. There's still a few things that I haven't covered, and they're things like the name and date of birth. And these really belong to the person. They don't belong to the employee. They don't belong to the fact that the person is employed. They belong to the person themselves. So we ought to show those as attributes of the person. And the employee number is really an identification of the particular employment, although very often we assign that to the person as well. Okay, so this is a Kaleido-style business model. So the first difference is that business models are conceptual models and represent real-world concepts and objects. Data models, or logical data models, define data structures for systems. And the second difference is the purpose of the model. And, well, the purpose of the business model, well, we covered some of that in saying that it describes real-world things, so it's meaningful to business people, so it's a good communication tool. But I want to go on from there and look at how that relates to the logical and physical models. So first of all, let's think about how we might make a logical data model that is consistent with this business model. And we might choose to make a normalized data model. Now, a normalized model enables you to hold information only once. So it's really good for transaction processing systems, and it's really good for master data management systems. It's really good if you want to do some governance of your master data, because when you change it once, you've changed it everywhere. That's the idea behind a normalized model. The only trouble is, if you want to do some reporting from it, then it's very poor for queries. So we might create a different sort of model, and we call that a star schema. And this is really good for performance of queries, but actually it's pretty lousy if you want to manage the master data, because it's duplicated, it's denormalized in those dimension tables all over the place. So it becomes pretty difficult to use. So we get two different models, these two extremes, which are good for different purposes, but they are both consistent with the business model. Now, if we now think a bit about the physical model, what would the physical model look like? Well, very often when we build a physical model, we make them look exactly like our logical data models, except that we turn all the attributes into columns and we turn the relationships into foreign keys. But you don't have to do it like that. You could do it quite differently. And I'm going to show you the way that the Kaleido physical model works and how that fits with the logical model and some data. So here we've got a model that is the product group and the pack product, just as a single relationship. And we've got some data here which shows the product groups as ice cream and the pack products as chocolate delight and chocolate stick. So what's the physical model look like? Well, this is the physical model for this particular data. And it works like this, that the product group, let me just try and get a pointer if I can find it. I can't find the pointer. Okay, I'll just have to talk it through. The product group and pack product are classes of business entity, and ice cream and chocolate delight are business entities, and there's a relationship between those in the physical data model. There's also relationships, these associations on the right, association between CVEs, which show the relationship between pack product and product group, and another one called association between BEs, which show the relationship between chocolate delight and ice cream. So this is the physical model for this data. Now, if I choose some different data, such as departments and divisions, now what does the physical model look like now? Well, actually it's the same. It's identical. But it holds different data. And we can see here now we've got division and department and industrial and corporate, but represented in the same structure. So when you buy Kaleido, you've already got your physical model. It doesn't change. Now this is a simplification of it, of course, but this is the idea behind it. So if we look at the Kaleido Dynamic Information Warehouse, we'll see how it uses these models. The business model is defined. It can be defined using the Business Information Modeler, or it can be defined directly in DIW. And it will generate a meta and reference data store which holds all the master data, and it is highly normalized. It also creates a warehouse schema, and the warehouse schema is a star schema, so good for reporting. So it does both those things. It creates both those models. It also creates a different model called the staging area, and this is another model generated from the business model. Then when we use it, we load data, and we report data, and we manage the data in the meta and reference data part, the normalized part, but we report from the warehouse schema, the part that's good for performance. So Kaleido manages both of these models. Okay, so the purpose of the model, the difference is the business model is designed to provide a common language for communication between the analysts and business people so that the analysts understand the business. In fact, often the business understand their business better when they've got a model. And it ensures that business people understand what their systems are going to support because they can refer to the model and say this is what the system will do. The business model helps us design the system which supports the true business need, and it drives consistency across a diverse set of systems. Logical data models define data structures for database design. That's its limit. data for a single system, or maybe for a set of systems. Okay, so what is the third difference? Well, the third difference is that there are a lot of semantics built into the business model. So let's compare these. The business model itself is metadata. It's defining the structure. But then within the business model, we have three things. We have the business transactions. These are the things we do in our business. And transaction processing systems manage these things that we do. BI systems measure the things that we do. Secondly, we have measures. These are the things that we measure about our transactions. And thirdly, we have master and reference data, which provides the context for those transactions. So that's the customers, suppliers, products, assets, and people. These semantics are important because they enable the processes within a system to act on the data in a consistent manner. If we don't have such a definition, then things can get very confused for the people developing systems and for the people using systems. It also helps people understand how the things will be processed. So let's have a look at a Kaleido conceptual business model. So this is an example of one, and let's just point out some of the things that exist in it. These are the transactions. They're coloured red in this diagram. There can be many different colours, but they're distinguished by colour in the business model. Then these are the measures inside the transactions. We've got sales quantity, sales revenue, or target sales. So they're the measures. And then these things are the contextual objects, the reference data or master data that we're going to hold, which give our transactions some context. So those are all conceptual model things. But we have a few other things. The Kaleido business model also covers some of the things that a logical data model would achieve, such as we would have attributes held within the model. In a general conceptual model, you don't normally have attributes, but we would put those in a Kaleido business model. And one of the key things about these is that they can change over time, just like these associations represented by the arrows can change over time. And then the other thing that we have are things called dimensions, and these help us represent the star schema. So they're almost down to some physical aspects of the model that we put into our business model so that it can drive the whole of the process from the business model through to the implementation. Now, if I took that model that I've just shown you and draw it as a logical data model, it would look like this. Well, I would say that's pretty bland. It's not very easy to see what's what. Where are the transactions? Where's the reference data? Where are the special measurement data? They're all there, but they're not easy to see. And so this doesn't become something that's good for communication. It becomes something that's good technically for implementation, but not really for communication with business people. Let's just think about some of the other things, some more semantics. Let's think about the semantics of measures. When you measure something, you really have to give it a unit of measure. I mean, if I say the temperature is 32 degrees, is it hot or is it cold? Well, in Europe, it's freezing. In America, it's freezing, but in Europe, it's really hot, right? Because we use a different unit of measure for our temperatures. Similarly, the semantics that are involved with currency enable us to do currency conversion. And if we understand that, then we can do currency conversion using triangulation techniques, which is what Kaleido does. Can you sum things up? Well, you can't sum temperatures, it doesn't make any sense. And you can't sum balance sheet items across periods, although you can sum them within a particular period. So there is a semantic here that needs to be understood. Logical data models don't hold this type of information, they just hold columns which are numeric. I want to talk a little bit more about measures because they're really important, particularly derived measures or key performance indicators. Understanding the semantics of these measures enables you to make calculations much, much more simply. So, for example, we might have a measure which is the target sales of our the percentage sales of our target, and it's defined as sales revenue divided by target sales multiplied by 100. Well, that's easy enough. But let's look at our model again, and we've got our sales revenue defined at a day level, and our targets defined at a quarter level. And our sales are defined for a customer, and our targets are defined for a country. So how do we make this calculation? Well, actually, you can see how to do it using the business model and looking at the arrows. If you follow the arrows to where there is a common point, then that is where you can make that calculation. So let's do that. The common point is country, quarter, and product. So if you summarize the actual sales data to country and quarter, you can make the calculation. You can make the same calculation at a different level. You could do it at the quarter and the brand level, or you could do it at the year and the market segment level. And you can see that by looking at the arrows in the business model. Follow the arrows and you will be able to make the calculation at any level higher up those arrow paths. Now, you can see that if you've got a business model to look at, but Kaleido does that for you automatically. From this one definition of a single formula, you can choose any level at which you report it. Now, things come in hierarchies. Pretty well everything comes in a hierarchy, and so we represent it like this in the business model on the left-hand side. And you could represent it in a data model in the way we've got on the right-hand side. The only trouble is you haven't got any history. You've only got the current snapshot. If you wanted to have the history, then you would have to make your model look like this. Now, that's relatively easy, but the DBMS doesn't help you process that. When you had the hierarchy without time variance, foreign keys would ensure that you had integrity of your hierarchy. But in this hierarchy with time variance, they don't do that. You have to work at it yourself, so you have to build that into your system. Typically, when we create hierarchies, we try and make them a fixed number of levels, like this one is, 3 levels. But in the real world, things don't work like that. Often we have customers which have got multiple levels, like a group company, and then a national company, and then some subsidiaries, and maybe some more subsidiaries, and then the people we actually do business with, who might be departments within that company. So a customer has multiple levels, and we don't know how many. And this classification scheme is a classification scheme which is the standard industry classification, and it has multiple levels. And some customers don't go in at the bottom level, they go in at other levels. So let's look and see how that would be in a data model. Well, without time variance, the customer would look like this, but the hierarchy of classification would look like this, and this sign means it's one of those, only one. But again, that's without time variance, and if we wanted to hold some changes over time and hold the history, it would end up looking like this. So it's quite a complex model now. Now this is quite doable. This is what Kaleido does under the covers, but processing it is quite tricky too. Kaleido does that too. So now we can have variable depth hierarchies. If you have a variable depth hierarchy like I've just spoken about with the customer, then you may want to break down the information at different levels. So we might want to hold the top level as being the group company, the next level being the national company, and then the level at which we actually deal with. And we deal with several different departments, the purchasing department, the finance department, the delivery department, and our transactions refer to those quite separately. They might even refer to something like the delivery location, which indeed refers to the delivery department. So quite a complex structure here. And we have different groupings and classifications for different levels of our customer definition. So quite a complex set of subtypes there, but fairly easy and clear to understand in that business model form. Let me show you the logical model form of it. Well, it looks like this, and that's quite tricky to understand. But where are the subtypes in here? Well, they're in there. I'll draw a line around them. These are all the subtypes. Not intuitive, but accurate. Now, when you come to think about the physical implementation of this, what you do? Well, you could implement one data table for each of those entities in that model, including all the subtypes. But then, if you had a delivery department would also have to have a same record in the customer entity and the same record in the customer structure. So you'd hold the same data 3 times. You have to manage the keys of that. And that is all doable, but it's quite complex. So you have to make some choices. There is another choice you could make, and you could implement it like this. You could say, well, we'll put all our subtypes into one record, and we'll have some optional fields within our table for groups, companies, customers, purchasing, and finance departments, and we'll have an indicator to say which subtype is actually being used, or which set of subtypes are being used in this record. So, yeah, you could do it, but it is complex. Kaleido automatically generates that for you and automatically handles it for you. Another semantic is the semantic of a calendar. Now, RDBMSs support the notion of dates, so that you could look at a similar date last year, or something last month, same day of the month last month. But then they're always using the Gregorian calendar, and you can't really have different calendars. So within Kaleido, you actually model your calendar, and many companies have a different calendar for their finances than they do from normal day-to-day activities. So they have a fiscal calendar. With the fiscal calendar defined, you can have year-to-date and rolling 12-month periods based on the fiscal periods, and you can have as many of those as you like. There's another aspect of time for which semantics are provided in the business model, and that is how to handle the data, historic data. Let's say we reorganized at the beginning of this year, so we've got different departments. We could look at all our business transactions according to our current hierarchies, the new organization. Or we could choose to look at it according to our organization as it was last year. Or we could say, well, we'll look at it whenever the transaction occurred. So last year's transactions according to last year's structures, and this year's transactions according to this year's. Kaleido provides that information, and the business model provides the semantic to achieve that. But it doesn't have to just be one reorganization at the beginning of the year. It can be every minor reorganization that takes place. Maybe you move a department. Maybe a person moves from one department to another. Everything is captured, and you can see how things were in the past using this semantic that is available within a business model. None of these concepts are provided by a data model. You can do it, of course, but you have to write complex code to support all of these concepts. The final semantic that I want to show you is one that we called mapped business entities. And to illustrate this, I'm going to show you the market segment, a market segment which is based on country and brand. So it's got two combinations from two different aspects of the model. And if you look at the matrix of the market segments, you'll see that XYZ brand is in the USA. It is a particular segment of the business, whereas elsewhere XYZ brand is just part of North American sales. So in Canada, it's part of those. And you can think of that a bit like a Disney store. You know, Disney is a brand, but it has its own store as well. So the structures can be very complex here, and you could do your management against those market segments, do your target setting or something like that against those segments. In a data model, you have to do some clever tricks like bridge tables in the star schema, and that's quite hard to do. Okay, I've talked a lot about semantics. It probably is the most important topic, but there are a lot of things here. So a business model contains rich semantics, different object types, transactions, measures, contextual objects, associations, all those different things. It has semantics about hierarchies, whether they're balanced or unbalanced. It has semantics about subtypes and supertypes, about calendars, about handling history of time and complex business segmentation. So what does a data model have? Well, it has the notion of data entities. It has some data types like numeric, character, dates, or nulls, and it shows some entity relationships. So pretty limited by comparison. Okay, I've got one more thing that I'd like to show you, and that is about, I've called it model constructs. But the idea is that it's not just the structure that tells you what your business model is about. It is also the content. Take a look at this structure here. What do you know about this company by looking at its data structure? Well, you don't really know very much. If I tell you that the company is called California Pioneer Foods, then you'd probably say, oh, well, that's the group company, and the regions are probably the San Francisco area and the Los Angeles area. But actually, if you look at the data, what you see is that California Pioneer Foods is broken up into regions which are Canada, Europe, International, and the United States. So it's got big business in Canada, US, and Europe, and then it's got international business across the rest of the world. In the United States, the company is called California Pioneer Foods Domestic. There's just one, but it's got some subsidiaries called Atlantic, Midwest, and West Coast. To a business manager, what happens if he decides that his international business is growing in Latin America and he wants to create a new region with a new regional office in Brazil, and he's going to make a change. He's changing his business model. He doesn't think of it as a minor thing, but it's staying the same structure, but it's changing the business model significantly. If we look at, the data model only shows the structure. So let's look at one example of this. The chart of accounts, absolutely key to a company. And let's look at its data structure. Well, the data structure of a chart of accounts is pretty well an account refers to a line item with some sort of hierarchy there. Pretty simple, probably the same for all companies. But if we look at the actual chart of accounts, then it tells us the things that we hold about a company. The operating profit might be a very important thing that we need to deal with. And it's made up of, well, the gross profit after distribution costs, the administrative expenses, and selling costs. And the gross profit after distribution is made up of some other things like gross profit, distribution costs, and volume discounts. So there's a complete hierarchy there, and this is quite key. It's documented in the company's accounts and published in the annual report and managed by the management of the business. So the governance of this master data is also really part of the business model. It's what makes it that company. Okay, so business models include the classes of things and the instances of the real-world concepts and the objects that they're about, whereas logical data models only have the classes, the structure of the data. So let me summarize. I talked about four things which are different. The objective. In a business model, we're talking about the business and the real-world objects and concepts. In a data model, we're talking about modeling data. The main purpose is, well, in the business model, it's the definition of terms, business terms, communication between people within the business and in IT, understanding the business structures, and consistency across the IT systems. In data models, it's just really about designing a database. The levels of semantics, they're really rich in the business model, but they're fairly basic in a data model. And the model constructs, while we're talking about the structure and the instances in the business model, we're talking about just the structure in a logical data model. So in conclusion, let's think about this. Whether you're using Kaleido or not, you should develop a conceptual business model. And you should use it for a number of things. You should use it to agree business definitions for objects and concepts, so everyone's talking about the same thing. You should display it on the wall and use it as a point of reference. Lots of our customers do this. They print their business model in a large form, and then they can talk around it and say, this is what we're talking about in our business. It's really powerful for that purpose. It provides a solid foundation to the validation of data models used in business systems. So if you're building systems, whether it be a data warehouse or a transaction processing system, you can use it to help you create your data models. But we don't very often build systems these days, we usually buy them. So it's also very valid when you're implementing systems and ensuring they're consistent. Different packages that you might install will have different internal data models. And it's important to relate their model to your business model. An example is in SAP, you might talk about a division. A division is a group of products, product categorization. That might not be the word that you use within your business, but you can map to that by having a business model. And really it's an essential component for business managers in their arsenal for planning and monitoring and controlling their company systems. So if you're in information planning, this is a really good tool. The ideal business model automatically maintains the underlying data models. We've seen that it could be automatic, and Kaleido's master data management and data warehousing systems do this. So to understand business modeling better, attend the Kaleido Advanced Business Modeling training course that John talked about earlier. And also the download of the Business Information Modeler you can have free, and you can use the modeling component of that free of charge. It's fully functional, and the location is on our website.